Okay, so welcome to a quick robotics homework thing, or homework problem. What we're going to be talking about is symmetric and skew symmetric. I'm just going to call it skew. Alright, so a symmetric matrix is a matrix it's a matrix whose transpose on A matrix, two underlines in the matrix, A transpose is equal to the original matrix. So in order to outline this would be like if you have 1, 2, 2, 3, and you take the transpose of it, it's equal to 1, 2, 2, 3. So both these matrices are the same. The transpose and the original matrix are identical, so that's considered symmetric. Skew symmetric is a little bit different. It's when the transpose is equal to the negative of the original matrix. So, in this case, it would be like 0, negative 2, 2, 0. If you take the transpose of that, and then make it negative, yeah, make sure I do this right and I don't screw with you. It'll be 0, 2, negative 2, 0, and then you have a negative out here. You put the negative out there. This will equal 0, negative 2, 2, 0. So you can see that this matrix is the same as the original matrix, 0, negative 2, 2, 0, but after taking the transpose and adding a negative to it. So this is the transpose, add the negative, you get the same matrix. So that's symmetric and skew symmetric. And what's interesting about these is that any large matrix can be broken down. So total A is equal to A of the skew symmetric, or the symmetric, plus A of the skew symmetric. And A is the subscript A, little a here is kind of a bad notation for skew symmetric, but since we've already used S, we have to use something else, so we'll use A. So going on with this, you can see that AS is equal to 1/2 of the total matrix plus A transpose, the transpose of that. So this is how you can get the skew symmetric from a certain matrix, or the symmetric from a certain matrix. And then A skew symmetric is equal to 1/2 of A minus AT. And that's how you can, these are two formulas that you will use fairly often in robotics in order to prove whether a matrix is symmetric or skew symmetric. And these properties are very useful in a lot of coming practice problems. And if you have a 3 by 3 matrix, typically if you have 1, negative 1, 1, negative 1, 1, 1, 1, negative 1, 1. This is the typical skew symmetric kind of matrix that you'll use. I'm sorry I have all ones. I could use other numbers. But this is 1. You can make this one 2, 2, 3, 3. But you can see that along this axis, this one's opposite to that one, this one's opposite to that one, this one's opposite to that one. And this is kind of the layout of the negatives. This is a skew symmetric matrix that is used very often in robotics because it's very helpful in the proofs of rotational matrices, which we'll get to a little later on. So this is a skew symmetric matrix layout that you might want to memorize. So negative, 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 just like that. And there you go. That's skew symmetric. Okay?